It's on mute. Hello, everyone. Good evening and good afternoon, good morning. Nice to be with you guys on today's section. So, today we'll be continuing from where we left off yesterday. Yesterday, I introduced you to fundamental parts of Python. Today, we'll be continuing from where we stopped and starting up with functions. Then we'll go in proper on how to work with files before we will then create a robust function to be able to integrate all what we've covered between yesterday and today. So this is still our Python class, the Python fundamentals for data engineering, and I really do hope you learn a lot. So just flow with me. If you have any question, drop it on the chat. My colleagues are there. We will get to you. And let's start what we have for today. Okay. I'll just take my face away and present the slide. Okay. Yes. So I hope you can see my screen. So yesterday we did stop at functions and yeah. So yesterday we probably stopped at functions. We're trying to see the flow of functions and how to use functions to make repeatable codes. So like I was explaining yesterday, function is like a block of codes. So you use it to make repeatable codes that can go into your pipeline. So you won't have to be writing some certain tasks over and over again. So a function will do one thing, it will make the code readable, it can make the code reusable across your entire project. Okay. So we are going to, but before we go into, yes, okay, this will be after the class. Then we moved on to modules, and then I was trying to create a custom module for us. So we'll see how modules are made from scratch. And in the course of that, I also did show some inbuilt modules that comes with Python. I explained that Python has its own standard library modules that it does come with. And some examples I gave was that with the OS, that's the operating system. I gave an example of the module on Python called JSON. And this JSON, it comes with its own list of functions. So in plain terms, how module works is that a function is a set of tasks embedded in a single block of code. So if you should call that function would apply, it would like work on that task, that specific task that you want it to work on. But a module is then a collection of functions. So it is a file, and it is a Python file. So that was the error from yesterday. It is meant to end with a py. But we are working with a Jupyter Notebook. And Jupyter Notebook, the extension of a Jupyter Notebook is IPYNP or something. So it's like a Jupyter Notebook extension. But a module should end in a .py file. That's a Python file. And it's a file that contains multiple functions. So if you define different functions that does different tasks, pile it up in a single file, that single file is then a module. So then you can import your module in your project. Then from that module, you can take the specific function you want from the module. So we're also going to practicalize that out there because it might have sounded confusing when I'm explaining, but it is always better when you see how it works. Okay. So I'm going to just go on to our Jupyter Notebook. So I did say we were going to use VS Code yesterday, but then I'm thinking about it. VS Code has a dark interface, and the interface won't really let us flow, like for you to see the output of the codes in real time and in a clear way for you to follow along. So due to that, we are going to have to keep on with Jupyter Notebook, where it is easier for you to understand and see the immediate output on Jupyter Notebook. So we stopped with funds. Okay, we worked with working with dictionaries, operations. Okay, once we are done with functions, we have to still look at these operators that we did yesterday. So like I explained, functions is a block of specific code that performs repeatable tasks. As long as the task is going to be repeated over and over again in the course of your pipeline, the course of the project you are working on, then it is best practice to embed that task in a function, right? So and I gave this example here with this block of code. So I have a list of dictionary right here. So this list of dictionary just contains something as simple as name and amount. So I have three rows right here. I have Ada, Bola, and Tunde with the amounts 150, 80, and 200. So what I try to achieve with this function is create a function, and the two arguments the function will take would be the records, right, and the limit. And this limit is that I'm trying to set a threshold. I'm trying to set a maximum amount. So if the amount in the record is greater than that maximum, the maximum amount I set, let it append. Remember, I taught the use of append. Append is a function that you can apply to a list to add more records into that list, right? So it is going to append that record into our empty list that we created right here. So if you practicalize this, we can then call out a function this way and get our results. Remember, I told the function is taking in two arguments. It's going to give the records, going to delete that the function is get big spenders. Even though this is not an ideal name, because if I should look at this months later, I might not actually understand the use of this function unless I have added, remember I mentioned yesterday, if you add a description in your function, so even months later, you can easily come back to know exactly what the use of that function was. So, but in this case, let's just call this function out. Remember, the function will be called out with two arguments. So the argument I'm going to be putting in here will be this list I created up here. So you put in the first argument, customers. So what it will do, it will go into the customer record. If the amount in the customer record is greater than 1,000, let me set the limit should be, let's set the limit as 120. We'll set the limit as 120. I didn't know this right, customers. So if the amount the customers spend is more than 120, it is going to result into my empty list here. So this function is going to do. So right here we can see that from here we know that Ada and Tunde are the two people that spent over 120. So you can see right here the result that was returned to us. We have Ada here and we have Tunde here. So that's a very brief example of how function work. Now let us see how we can then build a module that will contain multiple functions in which we can then call on our script. So like I said, if we are building a module, it is not going to be in a it's not going to be in a .pymp extension. It has to be a Python extension, right? So in this case, we are going to try and create a Python file, a .py file. Okay. This way to see. Python, if we create it as a normal notebook, we can also still, let's try with it is dot. So we'll convert this to a Python file and import it into our notebook. Okay. So we'll download this. Okay, this is hanging. This is not going to waste our time in this class. Let's just move on because we have over today. So go back. This is part of the standard fundamentals of Python that you need to understand when you're working with certain things. And there are different types of operators. We have comparison operators, we have arithmetic operators, and logical operators. But the reason why I didn't add arithmetic operators is because it is quite simple. It's something that we all know. We all know as our plus, our minus, our plus. But there's a very the comparison operators are solely come in conventional form. So aside the regular greater than sign and less than sign, greater than or equals to or less than or equals to, if you see this double equals to right here, you might think, okay, this is another form of equals to. What the double equals to sign is a form of comparison. It is trying to say, is this value equals to that other value? It is going to compare, and it is going to return either true or false. Comparison operators is going to return either true or false. So like the example I tried to give here, this symbol, that's the exclamation mark and an equals to, it is the opposite of saying of equals to. The exclamation mark and equals to is the opposite of equals to. So if you're asking Python, is 11 not equals to 11, which is false because 11 is actually equals to 11. So now let us see with our double equals to sign. So we're also going to take the example of trying to compare 11. So is 11 equals to 11? This is true. But if you want to go the opposite route, to opposite of of the equals to comparison, you're going to put the exclamation mark and put it out there. Now, if you notice that, why don't we then use a single equals to sign? A single equals to sign is just used to assign an object to a variable and assign the value of an object to a variable. Because if you notice from the course of all what we've been defining yesterday, when we are trying to define a variable, we use equals to sign, singular equals to sign. We say customers equals to, remember the ones we also create, we say num list equals to, records equals to. Just that single equals to sign is used to assign. So if you run this query right here, it's going to throw an error because it's actually want to understand what exactly you are trying to achieve, right? So if you want to make a comparison with Python, you have to use double equals to. This sign stands for the comparison, to compare if that value is equals to the other value, and it is going to return either true or false. Okay, so now moving on, just thought that should be something to note down. So now working with files and API. This is the main topic we are to cover today. And there are different types of file that you work in, that you will work with. We have the CSV file, you have JSON file, you have Excel files, and so on and so forth. But the most common ones most regularly you use is the CSV file and JSON file, right? So there are different ways to work with file. We have the regular Python way, we have the with open statements, and we have the easiest way of all to just work it out with a pandas function, right? And we are going to go through each and every single method of working with file, so you understand the different method and understand which method works best. Okay, so now if you look at the file fundamental, the main thing you need to understand is the schema, which is the structure that define how the columns are defined in the file, how the data types are, and the consistency. So if you should understand how the schema of the file type is designed, then you'll be able to actually work properly with that data. For example, a CSV file is simple. It comes in a row and a column. And CSV file most likely always have a header. So it comes with the header, that's the row, and the column, just like a simple table. JSON, on the other hand, is nested. It's like a dictionary inside a dictionary inside another dictionary. That's just the best way to explain it. A JSON is very nested, like it has different hierarchy of the way the data is structured. I actually have a sample right here. I open that I want to show you. was going to show us. So this is an example of how a JSON file looks like. I hope the screen being portrayed here. So you can see right here we have a outer dictionary called glossary. In this dictionary, it has this is like a key. Remember, I told you dictionary is a key value pair. This is a key, and it has this value, and this value also still has another value nested in it, has another dictionary nested in it. So JSON is a nested dictionary basically. And if you want to understand JSON, you need to actually look at the key and the values properly, be able to pick the value of the key you need when you're working with JSON. So a best practice to actually understand the nature of the data you're working with before you start importing or before you start diving into the data to make it work. So the first file type we'll be looking at would be CSV. Okay, so the CSV file, there are different methods to work with a CSV file. I'm going to walk through every one after the other. Okay, I did mention text file here. Okay, we are going to work with a text file first, and a text file is simple. It's a TXT file. Unlike a CSV that comes in rows and columns, a text file is just a simple file that you write things in and it returns it in the same way. Okay, so for the first thing first, let us create a text file from which we are then going to read from that text file and see how the output will look like. So if you see the code, the sample made here, I created a text file. This is the first method. This is the first method to work with a text file. So Python comes with a normal standard function to be able to work with your file. It is called the .write. It has .write, it has .read, whatever task you are trying to create at the moment, it has it, and you don't need to import it doesn't come with any other statement. It's simply just file equals to open, right? So once you do file equals to open, it takes in two main arguments. It takes more than two arguments, but the main important ones you should look at is two main arguments. The argument will be the file you are trying to open. In this case, the file doesn't exist yet. We are trying to make it. We are trying to write into that file. So you just give it the name you want to create the file as. Then the next argument will be what you want to do to this file. In this case, we want to write into this file. And that's why we're using the argument W. There are multiple other arguments that can come in place of W, but in the case of what we are trying to do now, we need to into this file. So we are using the argument W. Like I said, these are not just the two arguments that comes with the open function. The open function comes with more than two arguments, but for the course of what we want to do and to keep this simple, we are only looking at the important two arguments, which is the name of the file and what we want to do to write into the file. So we want to write into it. So we're then going to use the file.write. And the reason why using file.write is because when we made our open here, we stored it in a simply stored it in a variable called file. So then with my variable, I then use the .write function and simply wrote three lines. What this means is that we are going to see the output here with that the backstroke and the n. What this means is to create a new line. If I should create this file without the backstroke and n, we are going to see the outputs together and see how it looks. Everything is going to be on one single row with we've created names.txt. So if you look at we go in here to look at our names.txt, we'll see that the file, the records we put in here are just going to be on a single line with no line breaks. So you can see them, they are just in a single line. It's no line breaks. So the reason why the n is for it to do this, put back our code base here to make everything go into different lines. So now we refresh our names.txt to see change was implemented. Okay, so now we can see the names are now in 3 different lines because we use the line breaker. So we have choice on one line and they on the second line and they do this file. Okay, so remember this is just a simple txt file, nothing much. There's no much content in it. We are still going to move ahead to working with a proper CSV file and working with the JSON file. Okay, so now file, which we wrote the choice, the Ade, and Tunde. We wrote down 3 names into this file. So now we are going to practice reading from this file. So using the same open function, the open function for read is the same thing. Like I said, it works with 2 main arguments. The second argument will be, what are you trying to achieve with this file? Remember, in this case, we are now trying to read from the file. We are trying to read from the file because initially we've written into the file, so we use the argument W. Now we're trying to read from the file, so we're using the argument R. So if you want to read, we'll use the file, we'll use the dot read function, and dot read a variable we call data. Now, there's one thing you might be asking, that why then do these functions come with quotes? Why do we have to put a parenthesis at the back of the function? Remember that I explained when we're trying to create a function. When you're creating your function, the first thing is your def statement, and after your def statement, you notice that we always create a bracket. We always create a bracket when you make a def statement function. These brackets will take in, if the function is taking an argument, you put in the top to take in. In this case, this function is to take in 2 arguments. So we study please. I was going to leave this blank, or I would give it a parameter for it to be able to take multiple arguments. I'm not going to really go too deep into that for the course of this class, but I also wanted to point out the brackets that always comes with a function. So when you're saying this inbuilt functions like the dot read, dot write, and you can see they come with their brackets, this is a function that has already been created by Python, and there is no other way Python creates function than the regular def. So when they also created the read function on their end, they made it into a parenthesis, and when you are calling a function, you call it out with the parenthesis that is going to accept an argument or not going to accept an argument. In the case of when we're using the dot write function, we put arguments there because we needed to write into the file, but in the dot read, we are not putting any arguments there. We just want to read everything from the file and store it into a variable. So once we've opened the file to be able to read it using the R argument, we then use the file dot we use the dot read. So the name of the variable in which we open the file is, we call this file. So then using the file dot read function, we store the name because it is something that needs to be emphasized on properly. The reason why this normal method is not regularly used in production setting is because if imagine this file is a file with so many records, so many rows, that is going to be quite memory intensive, and you open the file without closing that file. As the file is opened, or as the connection is made open on the pipeline or whatnot, it is going to be consuming memory and is going to be taking up resources. And if you do not close it, it is then going to cause whatever source you're taking that file from, or the URL from, whatever source you're connecting to, it is going to cause slowness, it's going to make it lag and whatnot. Now that is best practice that once you use your open statement in function in Python, you have to also make sure you end it with your dot close function. But then this can be stressful to always try to remember every time, because it's not every time you open it that you might remember to close, unless you already made this into a proper function to say, okay, whenever define the function to open my file, and once the file is open, close it. But then that's a very stressful part to follow, because Python has made it easier. We don't necessarily have to use the normal method of with the open function, then trying to remember to close the function afterwards. We can easily just use another function from Python called the with statement. That is this third code base here. So the with statement, it automatically closes your file for you. So once you use the with open, automatically, that is why it's much better practice to use the with statement than to use the regular open and close, right? So now using the with statements, we're going to do the exact same thing we did with our normal method. We did that with open. It also takes more than 2 arguments, just so you know. But the most important arguments you need is the name of the file and the task you're about to perform, just the exact same way it works in a regular Python open function. So when you create your with open statement with your parentheses, obviously, the first argument, you put in the name of your file. The second argument, you put in the task you're about to perform. And in this case, we're trying to practice writing into the file. So now how it works is that you then have to give it an alias. Unlike here where we made it variable and we defined the file equals to the function and every other thing, we need to give it an alias, right? So if we do with open with the argument, you then name it as file. This is how the with statement works. And starts the rest of the statement. And in this case, we are trying to write to the file. So with the exact same method we used right here, using the dot write function, you will write into the file and write whatever contents you want to write into it. And in this case, I wanted to write a list of names. And I already explained what this backstroke n means. It is to make sure that each of these names stay on different lines. So we won't have all of them clustered up in one single line, but the names will go into different lines. So the choice, this backstroke n, it will make Ade go into the next line, and to make Tunde go into the next line. So the file will be readable. Now this is for txt file, right? And remember that it's just a very simple file format, just a simple file format, no rows, no column, just a simple statement. Now when you are reading with your with open statements, it is also the same way you use your regular open statements in Python, right? So we use your with open, taking the arguments, the name of the file, and in this case, the task we are trying to perform, we're trying to read, right? We're trying to read into the file that we created with your regular as file. I just like using the name, standard name as file, because you can name it any other thing you want. So if you want to name it for people to know that, okay, I'm working with a file, I file. So to just make it right. So now the next thing, next after opening the file and putting it in a read mode. So the mode right here is a read mode. And remember, like our regular Python function, we'll be using the dot read store the contents of the file into our variable data. So if we should go ahead and print data, it is going to give us everything that we stored in names.txt. Hence online, so we'll see it properly. So let's print out the output of data. Let's print data. So this will give our file right here with the choice Sunday, just as we wrote it into the file. So let's see if we can overwrite the output of what we have here in txt. So instead of Sunday, let that be Stella. So now going to our data, we see that what we have here now will be choice, Ade, and Stella, just as changed over here. So that's the two simple ways of opening working with a simple file, a txt file. Either you use the normal method, variable, use the open function. And remember, when you're using the open function, you always have to close. It is best practice to end the statement with the close function. But if you do not want to go through that hurdle, if you don't want to go through that stress, you will use your with statement. So if you do your with open, name it any alias you want. Standard practice for me, I just use as file. Then you carry out a transaction. If you want to write, if you want to use the dot read, you create it, and you do not need to bother about closing the files, because once you use the with open statement, once you're done, it automatically gets closed. Okay, so now that's for txt file. The next file type we'll be looking at will be CSV files. And CSV is a very common example of file because it is a regular table. It comes in rows and columns with the header. So this is an example of a list of lists. Let's call it list of lists, because it's we are trying to work it out in a way CSV looks like. So remember, CSV has its header. So in this case, the header is product and price. So this is a CSV with 2 columns and 4 rows. So the first row is our product price. The second column is our first item. So the first product book 100, second product pen, price of 50, third product phone, and the price of 1000. So this is how we created a simple list of a CSV file. Now, when you're working with a CSV, unlike your normal read statements or your open statements that automatically comes with Python, CSV has to be imported. You need to import that function into your workspace. Okay, you need to import CSV because there's a function in Python called CSV, and it comes with multiple no, actually it's a module. There's a module in Python called CSV, and this module comes with multiple functions. Remember, I told you that module is a collection of functions. So a CSV module, it comes with multiple functions. So we should import CSV module just like we did in our 1.5 in our space. So we'll be able to use the multiple functions that comes with CSV. And in this case, the functions will be after would be listed out in the second block of code in which we're trying to look at right now. So we are to create a CSV file called product, and the output of what we want to write into this product would be these records that we placed right here, we created using our lists, right? So we are trying to write into a CSV, create a new CSV called product.csv, and write into it the records that we created here. So the statement also goes regularly with open statement, which takes in two arguments. The first argument being the name of the file. So in this case, we are working with a CSV, so we end it with .csv. So that's product.csv. And what are we doing in this case? We are writing, so the mode will be W, right? So that's with open product.csv, mode of W as file. So what's the next step that we're working on? We are then going to use a function of CSV. So in this case, we're trying to write into it. And what are we trying to write? We are trying to write with the statement we create here, right? So we'll say csv.writer. Writer is a function that comes with the CSV module. So the CSV module we did, right, is csv.writer. So it is picking up a function from the CSV module called writer. And this function takes in one argument, which is the name of the file you are opening. So in this case, this file right here is standing in place for products.csv. I hope that is clear. The file right here in this bracket, it is standing in place for products.csv in write mode. And we store the output into a variable called data. So we can then easily now use the write row function of CSV to be able to write this data here into our variable called data. So let me break down again. First thing first is we started with our with statement, and our with statement, it takes into argument the first argument being the name of the file you're trying to work with and the mode. What are you trying to do? Would that be a write? Would that be a read? Would that be append? And so on and so forth. So in this case, we are writing. So it takes in the mode W. Then you end it, close the statement as file. Then you start your transaction. So in this case, we are writing into the file. So we're using the function from CSV called csv.writer. And the file in this case is representing the product.csv, which we stored as file. So now this data right here is empty because the only thing just did is to open an empty file. Because remember, there's nothing in product.csv. So at this point, data is currently empty because nothing has been put into it. Although we have an open file in a write mode, but it's currently empty. So now, how do we then put data into this empty variable? Remember, we created a demo data here called records with all these details. So then we look in our records that we created and put it into our empty data variable. Okay, that we then do it with our function that comes with the CSV. We use this function called write rows. So when you do data.write rows, it takes in one argument, which is what is the row you are trying to write into this CSV. And in this case, the row we are trying to write into this CSV is coming from this our record we created records. So right now, if we shift our data will then have the value of everything in our records. Okay, this is still taking our data from the previous one. So let me run this again. So data is coming in with everything that comes in, with everything that was written with our records, and with clearly because it's a CSV file. Because data has the content to be able to see the output right here on our project, to read the file with your with statement, it takes into argument the name of file, what is the performing. In this case, we want to read, so then we use more. So it as so in this case, we are then using the function of CSV called reader. It is just the opposite. When you want to write, you use the function writer. When you want to read, you use the function reader. So in this case, we're doing CSV dot and file, like a file standing in. So now that we have our variable called read data, just the same way as this our data, let me try and alias this out. Okay. So we have the read data that we created. So if we should print the value of read data, it won't be readable in the sense that you can see the actual data in it, because again, it is still a CSV. So now let's try to read what is in the CSV. Hence the loop statement right here. So what it's now doing is that it is now going to loop through each row. Remember, our CSV is then stored in this variable called read data. So using our for loop, we are going to now iterate over every row in our CSV and print out the results. Okay. So in this case, we are using pick as row. It can be anything you want, but just simple to say that, okay, for each is our CSV file that we've opened in read mode. So for each row in read data, print out the row. So this is going to loop through every single row in our CSV file and print out all the rows in our CSV file. Okay, in our CSV file. Remember, these are the rows in our CSV file. We had our three inputs, which is book, pen, phone, and you can see right here we have book, pen, phone, and price. We can take this a step further to put it into another list, but that's like creating a list of a list because it's already in a list right here. So three different functions that comes with the CSV module. We explore the function into the file we created. We explore the dot write rows function because in this case we're trying to write row after row. We're trying to impute data that has multiple rows into our file that we created. And we also explored the CSV. Okay, so now let's look at working with a JSON file. So just like a CSV file, a JSON also has its own module. You can work on a JSON with the JSON module. So you will do your import JSON statements. And once you import JSON module, it comes with multiple functions, just like a CSV. Now, this is a very simple example of how the JSON is a dictionary of a dictionary, is a nested dictionary, right? So in this case, we have our key as name, and it has a set of dictionaries nested in it as the name of the student and the score of the students, right? So we have our key students, and all this right here is the value of these key students. All these two rows, every single thing is the value of the key student. And just the same way, this is the value of the key student. College right here is the value of the key name. 95 is the value of the key score. So you can see when I say that JSON is a dictionary of a dictionary because it gets nested into multiple dictionaries. So you have to look at the hierarchy. What's meant by hierarchy is that, like in plain terms, which one is above which is the father of this, which is the how is it, what's the lineage behind this behind the structure. So look for the exact key, look for the exact value, then you'll be able to work properly with a JSON file. So now let's now practice working with opening and writing and reading a JSON file. So the example we're going to do right here is to create a JSON file, put in the values that we created right here in our variable called data. We're going to put in that. Okay. So first thing first, again, we are going to be using our with statement with our JSON. So if we say with open statements, remember I told you two arguments, main arguments. There are other arguments, but just two important ones you should note. .json in write mode as W. So we create a new file, products students.json in write mode. And this is, I guess I was feeling too lazy to finish writing file, but I also put it as an example here so you can know that it does not necessarily be as file. You can any value you want, any value you need, just something you know you'll be able to remember and you'll be able to work with, right? So in this case, for our JSON example, I announced the file as F. So this F right here is standing for our students in write mode. Okay, now what's the function? Because right now students.json is an empty file, so we're trying to write data into that empty file. So JSON comes with multiple functions. Like JSON is a module. Remember, a module, more collection of functions, comes with multiple functions. And one of the function in this case is the dump function. So the dump function is used to put objects into your JSON. Remember I told you right now we've made an empty JSON file in write mode, right? So now the next thing we're trying to then put in data into that empty JSON file. So we'll be using the JSON function called dump. So we'll be doing your JSON.dump, which takes in two arguments. The first argument is what are you dumping into this JSON file? And in this case, remember we created some files right here. A JSON variable right here called with our student key and the multiple values. So this is the first argument in your JSON.dump. Then the second argument is where are you dumping it into? What is the name of the file dumping it into? Remember, we stored our file as F. So the two arguments is JSON.dump, the file, the objects you are dumping into, the objects you want to dump, and what is the name of the file you're dumping it into. Okay, so right now we have a JSON file called student.json that would have the value of all these objects we created in data. So let's run this query and we'll just go and see how our JSON file look like. So now we've created a JSON file called student.json. What's this type of objects of typewriter is not JSON serializable. What's the case here? Oh, I didn't create JSON file, so about that. Okay. So have our JSON file. I didn't import the JSON earlier on. So we have our name student JSON that we opened and dumped this we dump this JSON into it. And now let's see how the file looks like without even opening it on our Jupyter notebook. Let's see how it looks like right here. So I can see our students. So as you can see right here, you see the way Jupyter Notebook opened the JSON file. So if you try this, click on it, it has two items in it. It has two values. And each of those values, it is also representing another key because they have their own value also. This is actually a beautiful way to explain JSON because Jupyter will break down the JSON in a way that you can see each of the hierarchy. You will see which one is on top and the values that are coming under that key. So let me collapse. So this is the roots of the JSON, right? If you collapse this, it comes with a key called students, and students comes with two items, as you can see specified right here. Now, if we should collapse students, you can see that students comes with two items, item 0, item 1. Can anybody type on the comment section while this number starting with 0? Why didn't Python just list out as item 1 and item 2? I explained it yesterday on why it starts with 0 and 1, or why it starts with 0 instead of 1, right? So that's just by the way. So now if we should open our key pair for what is in this first row, we have a key name with the value Collins. We have a key score with the value 95. So if you look at the second row, same thing. We have the key name with the value Stella. We have the key score with the value 88. So you can see how JSON is in a hierarchical form. You having each nested dictionary in another dictionary. So that's just by the way. So now that we've created our JSON file, we've written into the JSON file. Now let's practice reading from the JSON file. So with our regular with statements, your with open, remember it takes in two arguments. You have your students.json and you have, what are we trying to do in this case? We are reading. So the mode will be R. Okay. So we have with open students.json in R mode as F. So in this case, as F is also standing in place for our students.json in our mode, so it is open for us to read it, right? So now what do we do that we've opened the file? How do we read a JSON file in Python? You read a JSON file using a function of JSON called load. Load is a function that comes with JSON. So it does with the JSON module. So unlike opposite of dump, where you are writing into it, does load is a way to package what is already in the JSON file, because it is going to package what is already in the JSON file and store it into a variable. So in this case, we are storing the output into a variable called data. So we say data is equals to JSON.load. So we should print out the value of data. So now this query, print out the value of data. You see that everything we saw in our raw JSON format is what is the output of our print data. So you have your students, the key name, you have the values in students, and as you can see, each value has its own key value pair relationship. It has the name key and the score key with their respective values. Okay, so that's that about JSON. Now you might be like, oh, okay, all these steps are too complicated. You have to use your with statements, you have to then do the, but there's a simpler way to get this done. There's always a simpler way with Python. So instead of using your with statement with Python, you can also simply make use of the Pandas library. Pandas is a very powerful library in Python that comes with so many benefits. One of the most important, the most common use of Python of Pandas is to manipulate data. Pandas can be used to manipulate data. Like when I mean manipulate data, you use it to clean data, you use it to change your data type, use it to remove duplicate records, use it to do a lot of things in your data just to clean it up. But Pandas is also the easiest way to work with file, because remember the way we created our CSV file. I need to show you this again so you appreciate Pandas better. Because the way we created our CSV file is that first of all open it, then use the dot writer mode, write it with write rows and so on and so forth. Same way we have to read it, we have to use the dot reader function, then we have to iterate over each rows in the CSV to be able to read what is stored there. But now, if you want to use Pandas, you're only going to write one single line. First thing first, we are going to import our Pandas, because Pandas is not just right there in your notebook. You have to import your Pandas. So in this case, we are importing Pandas as PD. Now you might ask, why we import? What is the meaning of as PD? Because when when you import a library or a module or whatnot, you are going to be calling that module when you want to make use of it. Just the same way we do JSON.dump, we do most and part of the some people, you might find it hard or stressful to keep writing pandas dot when you want to make use of any function in Python in Pandas. So to make that easier, what a standard practice most people do is they alias the Pandas as PD. So it is shorter to do PD dots and pick whatever function you need than to start writing Pandas dots. So the shorter way to just easily write PD dots with any function you need from your Pandas library. So that's the reason why we do import Pandas as PD. So in this case, PD is now standing in place of Pandas, and obviously with every single function and modules Pandas come with, you can easily call PD and get the job done. Okay, so that has already saved you like writing formal letters or whatnot repeatedly. Now we'll be working with Pandas with a CSV file, and we will see how easy it is to work with CSV with your Pandas. When you want to work with a CSV file, the syntax you use depending on what you want to do. In this case, we want to read a CSV file. What you will simply just do is using your dot read underscore CSV, because in this case it's a CSV file we are reading. So the function you use will be read underscore CSV, because it's a CSV file you're working with. So once you get the read underscore CSV from the Pandas module, that is what forms this function right here that we wrote, p read underscore CSV. And the argument PD takes is, what is the name of the file you're trying to read? Okay, what is the name of the file you are trying to read? So in this case, we are trying to read our CSV that we created earlier on. Remember, we created a CSV file called products. We created a CSV file called products.csv. So we are going to use this CSV in our sample. We are working with Pandas. Here, you will see your name of the file. And again, remember I said we are going to use the file that we already created earlier on, which is products.csv. Then we will store the output in a variable called product. So in this case, product will then be equals to pd.read underscore csv and our file name, which is products.csv. So now the value of this products.csv has been stored into our variable called product, and it's not just a variable, it is called a data frame. Pandas stores data as a data frame. And what do you mean by data frame? A data frame is simply a row as a data frame, which is aka a column situation. So, and it is stored in a fancy way, just like a table. That is why you can see this output that I have. When we call out the value of our product, it will return our table in a very fancy way. You can see the header, product and price. You can see the rows, that's the row numbers, output of the data of the rows. Very clean. This is the work of Pandas. Pandas will store, okay? That's by the way. Now let us read into a JSON file. Just the same way it was very easy to read a CSV file, it is the same way it is as easy to read a JSON file. You will just simply write the name of the file you're working with, which in this case it is JSON. So previously it was read underscore CSV for a CSV file. Now it will be read underscore JSON for a JSON file. So it will be PD dot read underscore JSON, and the same thing, it is going to take in the name of the JSON file you're working with. Now remember, we already created a JSON file earlier on, and we named that JSON file students.json. Hence the reason why we are using students.json in our example of what we are reading. So right here, even if it is a JSON file, you will just use the p.read underscore JSON function. It is going to automatically convert your JSON file into a data frame, a simple data frame. Now remember, I said a data frame comes in rows. It's just a row and column with a header most times, and a header can be removed if you don't want it. You can add it in the argument of when you are reading your file and say you do not want header. It is going to be absent from your data frame. But we do not need that, so we won't be going into that. So the page has the value of your students. You can oversend name, which in this case the header is students, because that's the first and remember it comes in multiple so you can also do something else and say, okay, let's try and normalize this value to be more properly spread. When we mean normalize it in a way that, okay, all this nested value right here is going to go into a single row of its own. And that's another function of JSON that we cover in the scope of this class because of time. But it is called JSON.load. LOAD. JSON.load. We have JSON.load, we have JSON.loads. Depends on the type of task you're trying to perform. So you can read up more on that. It's a way to actually normalize these nested columns, this nested dictionary into a more viable form of a data frame. Okay. So if you have any question, let's get back any question before we then move on to the last part of what we have for today. So we've covered working with all types of data types, not necessarily all. Let me see if we have a sample Excel file here. So I would like us to also work with an Excel file, but it is the same thing like every other file that we've used. We're just going to simply use the extension read underscore Excel. That's just the only difference. So you can see how easy it is to work with Python. Just call the name of the file, the extension of the file, your pd.read underscore the extension of the file, and you'll be able to get your records in a data frame position. Okay. Now Now that we've covered extensively working with files, now let's move on to working with APIs. Like I said, that a middleman you can use to speak between two different interface, right? Between two different systems. So our API is the application programming interface. And how it works in the sense that it's like a contract. I want to just let me read out the explanation we have here on our slide, and I'll break it down into a way that'll be simpler, that'll be much more easier to understand. So API is a contract between systems that allows them to request and share data programmatically. Rather than manually downloading files, API enable automated real-time data extraction at scale. If you are there in the first class we did for our data introduction to, that's the first class with me, not Folonsho, your first class with me, where I had the introduction to data engineering, and I taught you of different fundamental techniques of data engineering. API was included, and I gave a brief example of how, if you want to connect to Twitter database, and I said obviously Twitter won't give you the access to the database or a entry into the data they have stored there, but you can request for this data through an API. So using an API will listen to your request, get what you need, then it will go to the other system, which in this example is Twitter. It will then go to Twitter, get your response, and return it back to you. So you're going to make your request. API will take that request, go to Twitter or wherever it is that you're going to, accept, get the response, and return it back to you. So that is why API is being used through a module called requests, because request has multiple functions in which you can use to get data using an API, receive the data, and store them. So, and if imagine if you're working with an API as opposed to going to the database, downloading the file, ingesting it. API is just a simple flow that will always be open right there. Okay, I won't use the word always be open because there are some APIs that have some limitations, because if you should extract so many data, or you're look getting so many data using that API flow, there's a limit to, there are some APIs that have a limit to how many data you can get at a particular interval. It's not listed in the scope of this class, but just a so you know concept. Okay. Now, API will make sure that okay, the process is entirely automated with no manual intervention, because nobody needs to come and download the file. It is not a file that is there or not there, because the database will always be available. Whatever source would always be available. You have to connect the API using your request function in Python to go into that database and get a response and return it back to you. So now, how does this request function work? We are going to look at it very soon. But before we do that, let's also see some theoretical parts of API. So I said API enables automation because you can schedule regular data pools without any manual intervention. So you can keep your data fresh and current, because it would keep bringing in the newest data from that source without any duplicate records, or without any missing data or whatnot. Okay. Another important or good thing of using API as a data source is you can request the latest data on demand. So if you are requesting the latest data, you won't have to wait for them to download the database and send to you, or you have to set up the database on your end to receive the data or whatnot. But if you should send data through an API, the data will remain on your end, and it will also get to the receiver, which in this case we are the receivers. Okay. Another important use of API is for scalable data ingestion. So you can extract large volume of data through an API. If you use connect, if your source is an API source, if you can connect API to your source, it's best fast to use the extraction using an API and extract the large volume without any latency or without any blocking, because again it is a direct link and nobody is having any manual intervention to do in it. Okay, so in like layman term possible, but just so that the official meaning is an application programming interface, acts like a middleman between two systems. You would ask for your information from system B and get your information back in system A. As simple as that. Now, let's look at the API request response cycle. So again, another brief explanation I gave here is that think of API like you are ordering food at a restaurant. So you are the client, right? You are the client in this case, which is you are the customer at the restaurant. So you are making a request to the server. In this case, the server will be the waiter. You are telling the waiter that this and this is what I need. I want rice, I want beans, I want spag, whatever it is that you need. So the server is not the person preparing your food. He doesn't have the food. He will just take your request, take it to the chef. The chef will prepare your request, give it back to the waiter, and the waiter will bring your response back to you. So API in this case is the waiter. So you're going to give your request, specify what you need to the waiter, make a request, then the waiter will then return with your response. Okay. So now what is the cycle of creating a API request? First thing first, you need to identify the endpoint. Every API comes in form of an endpoint, which is aka a wound. Aka a URL. You identify the endpoint, which is basically a URL, right? Then if you locate the API URL that has the exact data that you need to document any specific available endpoint and required parameters. And what do I mean by required parameters? There are some API that has multiple fields, and API comes in a JSON format. Most API comes in JSON format. So there's one thing that actually do come with API, but it's not going to be covered in the course of this course. It's called the dictionary. Most standard APIs, it comes with a dictionary. And that dictionary is going to easily tell you how to work with that API. So you will see all the fields that are available in that data. You will see how to work with those fields available in the data. So that's number one. By the way, then the second step is to now send the request. Once you've already located the URL, you've gotten the exact parameters you will need to get from that URL, which in this case is the field you need, how you want the fields to be returned, and whatnot. They are going to then send a request using the get. And it's not just get. There are different type of function you use with your requests. So in this case, if we are doing our get, we are trying to receive data from that API. If we use post, which is the second example that we put here, we are trying to give data using that API. We're trying to post, we're trying to send data to the other system. But if you use the get, you are pulling data. So you are getting data from that other system. But if you're using your post, you are putting data into the other system, right? So you will use the method to communicate with that API. So you will include any other query parameters or authentication tokens. In this case, there are some API that you need to have authentication token. So the authentication token is like a security guide to also limit your access to that API. But do not worry, the example we're using today is a public open API. So we are not going to be making use of any authentication token or any much more complicated parameters. Okay. Now, the first thing again, identify the endpoint, which is the URL, the API URL, and identify any required parameters you will need. Second step is to send a request, whether you are doing a get request or you're doing a post request. Send that request. Then the next step will be to pass the response, because when you're getting a request, right, it is not just going to land in a variable automatically. You need to create a variable that is going to store the output of that request. So that is best standard practice, to store the variable in a variable called response. So you are going to just say response equals request.get or request.post, or whatever the situation is that you are getting with your request. So once you pass your response into a variable, it's always in a JSON format. That variable is always returned in a JSON format, because I mentioned earlier on, API comes and stores data in JSON format. So to get returned in a JSON format, it's now be up to you if you want to convert that JSON format into a data frame, or if you want to easily straight up store the data into a database or a file, or use it for the next step of processing in your pipeline. Okay, so that's enough talks and talks. Now let's move on to actually seeing how the request work on our Jupyter Notebook interface. Library in Python, you have to import it. In this case, it's already stored in our Python, so we don't need to actually do anything complicated like start doing your pip install or whatnot. It's already a standard library that comes with Python. You just need to import it into your workspace. So in this case, we've imported our request, and I thought the request can be request.get, it can be request.post, it can be request. Any other mode you want to make use with the API. But today we are doing a request.get because we're trying to get data from that API. Okay, so now what's the first step that I mentioned in the last example? You need to identify indicate the URL. So in this case, this is the URL we'll be making use of. It's a public JSON URL. Just store it in a variable to make it easier for us. We say URL is equals to the link to the API. That's the endpoint of that API. Now, what's the second step? Second step is to send your requests. So ignore this response is equals to, just ignore it for now. Ignore it for now. So this is the next step. That's our request.get. In this case, we are doing a .get because we're trying to get data from that URL. So give me a second. So in this case, we are getting data from the URL, hence the use of request.get. Okay. Now, what's the third step? Pass your response, the request that you've gotten, pass it into a variable, store the response. That's the reason that's the reason request.get, because we got data, store the response into a variable. Sorry, just give me a second. Um, please, I hope you can see my screen, and I hope I'm audible. So we are going to do the first step, which is to identify our endpoint, which is what we did right here, the endpoint of our API. The second step is to send the request, which is what our request dot get response. So that's why we did. And now after that, remember I told you this is a JSON format. This response is in form of a JSON, so it is still not in a it's still not in a readable format that we can make use of. Hence the need of using the .json to be able to store the value into a variable. So that's why we're going to be using the function right now. Our request, what we sent, what we wanted to get from the API, it is stored in our variable called response. Right now it is stored in a variable called response. So the next step now is to then use our .json on the response. So if you store the value of our data and response.json in a variable called data, now this is a JSON formatted variable. We can then use the .data frame to convert this into a pandas data frame. When you have your regular variable stored with data and you want to convert it into a pandas data frame to make it easily readable with the header and the rows and the column, you will use the function pd.dataframe. Remember that we stored our pandas, we named it as pd, hence the name pd, then dot data frame with the data you want to convert into the frame. So right now, our data is stored in a variable called df, and this df is a pandas data frame. So if we should do df, let's try and print df. So now if we should print df, we see the output of what we had in our API. So from this API, the data was stored there. It came with 4 different columns from what we could see. From what we can see here, it has the ID column, has the name, has the username, and has the email. If we didn't convert it this way, let's try and see how data would have looked like. So response is equals to request.get. So we're getting from the URL. Now we pass it into a JSON. And if we should read what is in this JSON format, you can see right here that is nested with the dictionary of a dictionary. Right here, we can see that we have our list of items here with the address stored with this is the key, this is the value, the key email, the values, and so on and so forth. And this is quite messy to look at. Right? So in this case, that is the reason form of rows and columns. Work with your API, connect them. We don't need to have any database connection or what. You can see it is just as simple as getting the endpoint, just a simple URL, get your request, store the response of a request, convert it to a readable format. In this case, I just simply converted it to a data frame and worked with it. Okay. So every time the request, you get a response, yay, everything works and good. It's not every time that what you actually want to achieve is what will happen in your pipeline or whenever you're working with your codes and what. Now that there's something called try and error, it's called try and error block. And this try and error block works in a way that you are going to assume that this code is going to break. It might sound somehow, but like there's a certain something that one of my mentors to mention that when you're writing the code or when you're building something, build it with the with the thought of this is going to break. Don't build it with the confidence of, oh, this is going to be perfect, so it is going to work out great. Build it with thoughts of this is going to break. And when you build it that way, you're going to implement preventive measure, not just preventive measure. You're going to implement proactive measures that even when it break, you can easily see the particular instance and the reason why the pipeline or the code base breaks. So in this case, one of the most popular way to implement this solution is using the try and accept block. So what this means is that you're going to tell your code base, try the regular tags. In this case, regular tags is to do your get statement, request.get, store it as a JSON, and okay, we are stopping at this stage now, but we could also continue and into a data frame. We could have completed it here, so it doesn't matter. So let's convert this into a data frame, doesn't matter. Okay. So then we are going to then print, oh, request was successful. But in a case when it doesn't work, so if we try to get requests for this with the other tags and it doesn't work, we're then going to do except the try doesn't work, bring out the exception as E, because a try and error block automatically stores the errors in the exception in a variable called exceptions, like it is inbuilt that way. So to then make it shorter to write, you can now store the exception as E. So if you then print out the value of E, you can easily see the error that happened. So if you cut your particular, like, oh, okay, this has worked or whatnot, you can, or it's then failed, you can easily see with try and block, oh, this is exact stage where it failed, and this is why it failed. Right? So the better way of debugging, monitoring, and making your code better, basically in all sense. So now I'm going to do something, because our URL has been defined in a way that obviously it's going to work because it is a public URL that is easily accessible. So let me remove one letter from this just to make it a wrong URL. I hope this doesn't exist. I hope this endpoint doesn't exist. So what we're trying to work here, what we're trying to showcase here would work. So I'm redefining my URL. I remove the S from the back of our endpoint, and let's see how it will work out. So now, oh, so that means it's actually an endpoint with /user. So let me change this to another word. Okay. Okay, if it says request successful, now let's print out what we had. Let out what we have in diff, because I would actually like to see the data that is stored in /team. It's an empty data frame. So the request went through, but it's an empty data frame because regardless, it exists. So I mixed up the URL. I want us to just see the output of the try and accept block. So you'd see exactly how it will return the error and give you exactly where your code is missing something. So from what we can see right here, I made up an endpoint. I switched up the right, made up a completely different block. So as you can see that it's returned the error, it is expecting a value in line 1 column 1. It is expecting a value, but obviously this URL is not a proper endpoint. It does not exist. hence why it is not returning anything. We could have made this more elaborate, so actually type out and make it exactly tell us what type of value is are we meant to put in. We can make it more elaborate to also try to point out the exact error code it got from the URL, because when you try to make a request, it is to a say what do you call, what do they call it, XML request or whatnot. So it should a either your for or your each. We're not going to go too in depth of that for the scope of this class. So now let's simply go through a function that is going to do something very simple. It is going to extract data from our URL and store the response, put the response into a JSON, and print it out if it is successful or not. Okay, so remember rest for audio time. Let me simply users. Okay, so define our URL right there. Then now we are defining our function. So remember our function, you start with your def statement to define your function. Then our function name in this case is extract data. And what's the data we're extracting from? We are using it is going to accept one position URL. Then starting our transaction, we're using the try and accept block. So to try to get requests from this URL, store the request in a variable called data after converting it to a JSON format. Then, if it is successful, to print out request successful. But if it is not able to get any response from that URL, so the reason why this statement was still getting a response, like even though it's an empty data frame, because the URL existed, regardless of whether there was data or not. The URL, the endpoint exists, an API. So even though it doesn't return anything, it is still an open endpoint right there. But in the case of where I like completely removed every logical sense from that URL, obviously it's not a endpoint in which it can return any data from. So in this case, our try and accept block, we send it out to the endpoint to get data from there, get any of the JSON formats in which we store into a variable called data. Again, we missed out the step to convert the JSON stored in data into a proper data frame called df. And if all this gymnastic doesn't work and there's an error, it should print out the error message from the variable. So right here, if we just simply call out your function, function is extract data, right? Then with our argument is URL, and this is our function extract data URL. You can see right here extraction successful. So I didn't spell successful well, so let's just write the request successful in this case. Okay, so that is that about API, a brief rundown of how to work with API. So now the best practice when working with file or API is, like I said, you need to validate your schema. You need to inspect the column of the file, inspect the data type after reading the file or API, because if it's not inspected to know exactly how the data is coming in, if there's a schema change or a data change that is not compatible with where you're going to dump the data in, something might break in transmission that you will now come and spend days trying to figure out. Another thing is to handle the error gracefully, which is what we practiced. You wrap your operations in try and accept block and log failures for debugging. There's something called logging, but I'm not going to cover. I think we'll still cover it later on. So there's something called logging that you can also add to your try and accept block to make it more elaborate, to see the exact errors that happen. So when you come in in a like blink of eye. You can easily fix whatever it was that broke in the pipeline, right? And that is to document your data. Like even if you have the source, you've written it out on your code base and whatnot, document it and push it to GitHub, so you can always have access to know to the documentation later on, right? So that is that about that. Now, the next step is to practice with real APIs. Just like the API that I use, there are other public APIs out there which you can practice from. That's the API endpoints. There are some APIs on GitHub, there's APIs on News API, there's APIs on Open Weather, and a very popular one people use, there's API on Twitter. You can use Tweet, I think it's called tweet.com or something for developers. Just do a brief research on that. Now, there are other techniques to also look at for to also practice when you're working with API. You need to learn authentication, you need to learn pagination and rate limiting. Remember, I told us what authentication means, that there's some API that are not public. You need to have access to be able to work with it. Even though the access might not be hard to get, they will just most likely ask you for your email address or whatnot. But it's a way to monitor what you are doing with that data, a way to monitor and limit the amount of times you are pulling or getting data from them, right? Then there's the pagination. What pagination means is that if you're getting the data that's on multiple pages, how are you going to write it into where you're dumping it into? How will you write it when you're dumping it into the source? You need to set how the pages, how the data will be written into different pages, so it will be easier and more structured when you're picking the data and dumping it into your source. Another thing, another technique that you should have in mind on is rate limiting. Like I told you that there's some API that has some certain rates in which you can request for data at a particular interval. So you need to, if you're setting up a pipeline to like keep running for an unlimited number of time, you need to set that rate limit at this particular time. If you've retried, like let's say like retry of 5 times, just set that limit there of which it can call out that API without causing a blockage, right? So now you can combine your file reading and API calls and just create a simple workflow. I believe this will be part of the quiz on further week to come. So if you can watch back on this video and practice on it, that would be best. And I believe the slide will also be shared with you. And I will also share this code base, the Python fundamental code base. I would share it also with you, with my fellow colleagues, here to be shared on LMS. So these are some best practices that we've listed on over and over on how to write your code with your Tranex and with some certain perspective behind it. So first thing, as I said, always you need to write clear code, give your functions descriptive names, give a variable descriptive names, and add comments to explain the why behind your logic. So if you look at it month later, or your team members are looking at it month later, they will also appreciate you because they won't be stuck on trying to think of what this does or what the variable does, right? Handle error gracefully with a try and except block. You test your functions before you integrate into your pipeline. Test it out in small ways. You can test on a Jupyter notebook. You can even go as far as testing it on your Visual Studio. So organize and document, structure your code into modules, document your assumptions, create README. In this case, it is when you're pushing your file to your GitHub. I explain to you what a README does. It's like an intense description of what the project is about. So it also give you about the setup, how to use, how to reproduce it. You need to be able to document everything properly there. So when you go back later on, you will be able to easily understand what the project is about and use it as a reference in future time, right? So now that will be the end of what we have for the section for today. And I really do hope that you are able to, and I hope you're able to pick up what we had to cover. So if you have any question, like I said, we can drop it on the comment section or try to reach out to me on LMS, and we will be happy to respond, or we'll be happy to respond and give you clarity on what you need. So any question? So, in the absence of no question, I would actually assume that we really did enjoy today's section, and we did grasp what it is that I came here to offload to you all. So, thank you for having me, and I would see you next time.